with the delay in launch of the SpaceX Falcon 9 delivering the Dragon spacecraft to the International Space Station, there will now be 6 crew members on board to assist once it arrives and berths to the station so that they can assist with unloading and loading of that cargo vehicle. As mentioned, there's quite a number of experiments on board that Dragon spacecraft once it does launch to the space station. There's also obviously a great number of experimenters eagerly anticipating its arrival at this station. Let's go live to the Kennedy Space Center in Florida, where Space Exploration Technologies continues that processing for the Dragon cargo spacecraft. Among that cargo is hardware that's going to support the largest space garden ever on this space station. It's flying now so that the team can conduct a validation test of that hardware. Joining us this morning is Dr. Joya Massa, a project scientist in the station's Ground Processing Research Directorate down at KSC. I think I got that right. She serves as the science team lead for this payload test. And Dr. Massa, it's great for you to be here, and thanks for joining us on Space Station Live.
Thanks for inviting me, Kyle.
Well, you know, we've grown plants in space on quite a number of probably shuttle flights and space station missions, and but you're actually trying to do something a little new here. Give us the background on the Veggie experiment and walk us through your team's goals.
Sure. So Veggie was designed and built by Orbital Technologies Corporation, or Orbitech, a company in Madison, Wisconsin. And then Orbitech and NASA collaborated to partner to bring Veggie to flight. And Veggie was designed to be, as you said, the largest plant garden, essentially, on station. It's going to hopefully provide food for the crew. Also recreation. We'll be able to do science within Veggie, a lot of different science related to plant growth. And we expect it to also be something really interesting for education and outreach.
We see you've got a prototype of the flight hardware there next to you. How about giving us a little tour?
Okay. So Veggie consists of an express rack mounting plate, which is the part of the hardware that will mount to the rack on ISS, and that will hold the LED light cap. So Veggie is lit with light-emitting diodes. We have red, blue, and green. The other parts of the hardware are a transparent, accordion-like extendable bellows, and then a reservoir in the bottom, which will provide water to our plants. And then the plant pillows are the part of the hardware where we put the media, like a soil, and the fertilizer, and we can plant the seeds in them. And then these will interact with the reservoir, and they're held down with some bungee cords. And so that's how the whole system will work. It's pretty simple. It's designed to be low mass, low energy, and it'll collapse for launch.
That's really interesting. What is the once it gets on orbit? What's the your hardware validation plan, if you will, once it gets there?
Sure. It'll be installed into the express rack first, so there'll be some unpacking and some construction activities, and then the crew will program it. And they can program the lights, the light levels and colors, and also the day-night cycle for the lights. Once they do that, they'll install the pillows that we've sent up there. So we're sending them up there. Everything's dry. And then they'll prime the pillows. So they use this type of a bag with a syringe to take water from their galley and add it to the pillows. And they need to do that to fill up the pillows with water initially to start that water column off. Once they do that, they will close the unit up and then fill the water reservoir, which can be accessed externally. And that'll start the plants growing. After the plants start growing, there are a few activities, but generally they'll just check it every day and make sure things are right. They'll thin So we'll have 2 seeds planted in each pillow just to make sure that we get good germination. And they'll reduce that to 1 plant per pillow after the plants start growing, about a week after the initiation. And then it'll just be taking some photographs and refilling the water reservoir periodically until they're ready to harvest the plants. Now, with this first set, we are going to do microbial sampling. So the crew will swab the hardware and the plants, and then they're also going to harvest the plants and freeze them so we can bring them back and have food safety analysis done, because we need to make sure there's nothing harmful growing on the plants that could endanger the crew before we allow them to eat anything.
Oh darn! That was going to be one of my questions to you, because I know everybody would like to know: do they actually get to try what they grow on orbit? But I guess not. We'll have to wait till they get back. Talk to us about how the differences between this this greenhouse, if you will, and others that have flown previously on either shuttle flights or other station missions.
Right. Well, as you said, this is the largest plant chamber that NASA has ever flown. And one of the big differences are these transparent bellows, because for the first time, the plants aren't going to be growing inside a sealed box. They'll be growing in something that the crew can see and enjoy as they just go past. This will be in the Columbus module of the space station. And so we think they'll actually, enjoy walking past the module. The watering system is also very different. As I said, it's a low energy requiring unit because we want to be able to grow plants with less energy input. So instead of using an active watering system like a pump and an irrigation system, we're using this passive wicking system. So this is the first time we're testing this system. We really hope it works, but this is a hardware validation test, so that's one of the things we're going to find out.
Well, obviously you may have touched on this, but beyond the food production itself, obviously this experiment can provide an aesthetic or maybe even a recreational benefit for the crews on orbit, right? Mm-hmm. Yeah, one of the goals of this is to see how the crew enjoy it. So we are providing questionnaire for the crew both on orbit and when they get back to Earth to see, what did they like, what did they not like, what may we want to do different in the future. So after they harvest this first set of lettuce plants, our goal is to grow a second set of pillows that actually are zinnia. They're flower. They're small daisy type flower, and they come in different colors. We have an assortment. And this is because, we know that we're not letting them eat the lettuce initially, so we want to give them something they can enjoy. The frozen lettuce will be brought back on SpaceX 4. And once we do the food safety analysis, we have a third set of pillows up there that are identical to the first set with the same lettuce seeds. So we're going to work with the crew office and the flight surgeons to try and get permission for the crew to grow those and eat them. So it just depends on the results that we get. But hopefully they'll enjoy the flowers and the lettuce. And we expect to see this a lot when crew are working in Columbus. We should see this unit. So I think people on the ground may actually get to see the plants growing too and enjoy them. Well, I know you and your team are excited by it, but I understand also that you have students that are involved in the development of this experiment as well. Is that correct?
That's correct. We've had many interns here over the summer and other semesters that have helped with the plant science side of it, with the engineering side of it. We also had a couple of high school science teachers here last summer that got to help out with things, and they brought this information back to their classes and shared it. And we hope to continue that with more teacher training programs in the future, where we use Veggie as a system that they can be involved with and translate into some type of classroom activities. Orbitech has even developed a small space garden system that can be used in the classroom that's similar to Veggie with the same type of bellows. So we really want to bring this to the students as well, because finally we're growing large plants that people can relate to, that they can think about eating, and I think that could have a big impact when people like students are thinking about growing their own vegetables.
Yeah, absolutely. Well, look, we really appreciate you taking some time joining us here in Mission Control today and talking about veggie. It's very exciting, and people love to watch things grow. I know at my own house I like to see things turn green in the springtime, so I know the crew will find that fascinating as well. So we appreciate you joining us, and hopefully you can come back and talk to us again with some of the results that you see from this first set of experiments. So thanks again for joining us.
Thank you, Kyle. It was my pleasure.